Welcome back to the next module on the Rako training. Next, I want to talk about wiring on the wired side of Rako and get into some detail there. So here's a wiring diagram. Here you can see we've got 1, 2, 3, 4 rack 8s. So that's 32 circuits available to us. And I've notionally documented what each circuit is for. And this is where the rack link comes in. So remember I said earlier, for every 4 rack 8s, you need a rack link. And each rack 8 gives you 8 circuits, and you can mix and match different modules for dimming, switching, 0 to 10 volts, DALI, etc. My rack link is the brain, and you can see the blue cable here is my Rako bus. This is a Cat6 cable that connects from the rack link and then daisy chains through all of the keypads. And the rack link provides the power on the bus to power the keypads. Remember, these keypads are always online, always available, and have backlit LEDs against the buttons, powered off of the rack link. I also talked about the hub, really important. The hub, that gives you access to the app and automation functions and macros and all good stuff like that. The hub, the hub is also powered off of the rack link. There's a little RJ11 connection on the hub itself and an RJ11 connection down there. So the hub is on the bus, talking to the Rako system, and is powered off the rack link. And also the hub is your bridge to the network. So you'll have a patch lead connecting the, or a Cat6 cable connecting the Rako hub through to your Ethernet switch for your main network for the house. So it's got connection to the internet and so on for the app to work, obviously. So that's a basic layout of a wired system, fairly straightforward. And if you need more than 32 circuits, then you build another stack. So I've added another stack here of 4 rack 8s, adding another 32 circuits. So I've got 64 circuits in total. So I've now got 2 rack 8s. So the rack 8s daisy chain between each other on this blue line showing the Rako bus. And if I wanted another 32 circuits, I would have another stack of 4 rack 8s with its associated rack link. So that's it, really, pretty straightforward. This can get a bit arduous if you have lots and lots of keypads going between, I don't know, 2 or 3 or 4 floors of a building. One massive long daisy chained Cat6 for all the keypads could be not totally ideal. So enter the rack star. This is the rack star, and this allows us to star wire our bus. It's basically got 18 connections. We kind of notionally have 1 is input and 18 is output, and then I can have all these branches all connecting off in different directions. So I don't have to have one massive daisy chain for all the keypads. I could, for example, have a leg that does the ground floor, another leg does the first floor, another leg does the second floor, with another leg, I don't know, goes to an outbuilding or something. So with the rack star, we're able to break the daisy chain and star wire, which is a lot easier to troubleshoot if you do have a wiring problem, because you can isolate these little switches here next to each punch down. You can flick that switch to isolate a leg. If you have got errors on the bus that could be caused by a cable short or a cable break, then you can basically isolate each leg of the network until you find the one that's got the problem, and then that, you know, rather than troubleshooting 30 keypads on one big daisy chain, you might only have 5 keypads to troubleshoot on one particular leg of a star wired infrastructure. So we really do recommend using a rack star. And this is a sort of another diagram showing it in action here. So I've not bothered putting the rack 8s in, but you can imagine the rack 8s are associated with this rack link, and you've got as many of them as you like. That's kind of irrelevant for this conversation. This is all about the keypad wiring. So here I've got one Cat6 coming from my however many rack links that are daisy chained together at the head end into the rack star. And then I've got 4 legs here and 4 legs here, and now you can see I've only got 3, or some cases 2, and in one case 1 keypad on a particular leg of the star wiring infrastructure. So a rack star is definitely recommended for bigger projects where you've got lots of keypads. But as I said, if I have a problem on my network, on my Rako bus network, I can isolate and then figure out where that is and narrow it down to a smaller subset of keypads. If you imagine that was one long daisy chain of 30 odd keypads, that's going to take a long time to troubleshoot where the wiring fault is. So star wiring, definite must. Use a rack star on bigger projects, and only daisy chain if you only have a small handful of keypads and you're willing to troubleshoot them if there's a wiring fault. And obviously a really big project, you can have multiple rack stars if you want, because remember there was connection 1 was the input, connection 18 can come out and go into connection 1 of another rack star, and then I can have more daisy chain, more star wired legs of keypads. In fact, I could have different buildings where maybe I've got a load of rack 8s with a rack link going into this rack star with the keypads in this building, and then I've got another building and I've got one Cat6 cable going out to another building that's got these keypads in it and a rack link and a whole bunch of rack 8s. So it gives you lots of flexibility in the topology of the Rako bus wiring. So when it comes to the wiring, you're probably familiar. Cat6 cable has got 8 conductors, pair of greens, pair of oranges, pair of blues, and a pair of browns. And this is what Rako uses them for. You can see that on the right hand side there, that's what the Rako system is using them for. You don't necessarily need to worry about that too much unless you're having to do some detailed troubleshooting. But you can see that you can see immediately we're doubling up on the power. For you've got the brown, white and orange white are the positive connection on the power, and the orange and brown are the negative connection. So we're doubling up on the cores for the power to avoid voltage drop on the longer runs. If you have a project with only 4, a cable buried in the wall that only has 4 conductors, like a Lutron cable or something like that, then you can still use that. If at the time of ordering the keypads, the keypads come with traditional IDC punch downs, but if at the time of ordering you specify, I don't want punch down, I want screw down, because obviously Lutron and Crestnet type cables are not punch downable, they're not the right gauge. You can order the Rako keypads with screw down terminals instead, and then you can reuse some existing cable infrastructure that's already in the building and not have to rip it all out and replace it. So that's good to know. One little thing you do need to know about is there are some jumpers on the keypads, and where you've got the end of a daisy chain line, you need to set up the jumpers as per the middle one on the end of the line. Any keypads before the end of the line, you don't need any of the jumpers set on them. And if you're using a rack star, then you at the end of a rack star line, then you set the jumpers in this way. So it's basically just terminating the Rako bus so that the current voltages and so on are correct at the end of the line. So set those jumpers on the keypads accordingly. So anything intermediate, don't bother. End of a daisy chain is the middle one. End of a rack star line, then it's this one. Another very useful capability is the this thing called ether bridging, which is very, very powerful. This really can totally alleviate any concerns about wireless range, for example. So in this example here, let's say I've got a fairly big property, and for some reason I've got a keypad at one end of the property that needs to send a wireless signal to a wireless dimmer at a different end of the property, and the RF range ain't going to make it. So one way, we did mention a booster earlier on, which is one way of solving that problem, but another way of solving that problem is leveraging the Ethernet network. You could actually use Rako hubs as kind of wireless access points, if you like. So maybe imagine hub 1, maybe it's a wired system, let's say, and hub 1 is a wired hub plugged into a rack link, and you've got some outdoor lighting that you forgot about and didn't cater for. So you could put in a wireless RMT500, maybe, I don't know, a junction box or something out in the garden, but you want a keypad inside the house to be able to send a signal to that dimmer, and that dimmer is too far away from anything that can talk to it. So what you can do is you could buy a wireless Rako hub, which comes with a power supply, doesn't need to plug into the network, into the Rako bus. That could be a wireless one with its own power supply, and all you've got to do is plug it into your data network. And if you enable ether bridging, which is a tick box in each Rako hub, then every time this hub sees an RF signal, it will send it to this hub over the data network, and then this hub will transmit it. So now I could have a wired or wireless keypad at one end of the building or in a different building, control a dimmer that's somewhere a long way away, interconnected over the IP network. So any signals this guy gets, he sends to this guy, and this guy then transmits it. So you can dot these things around within multiple buildings, and then you have no issues in terms of range, no range anxiety. So that's a great feature. Talking a little bit about wireless, what Rako uses is 433, well, what is available to us is 433 and 868 megahertz. They're two frequencies that are readily available in the UK, frequencies that are unlicensed, and they are, even though they're megahertz, they're actually deemed as quite low frequency. So a lot of things, this is what this chart is explaining, that a lot of things that need wireless tend to use 433 or 868. If you think about Wi-Fi, which has definitely got range limits, that's in the gigahertz spectrum. So as you probably know, higher frequency signals attenuate quite quickly. Lower frequency signals can go further. So 433 and 868 are great because they can go further. They've got longer range. They're better at penetrating through walls. And what I started to say a minute ago is that what Rako actually uses is the 433 out of the two, which is the lower frequency of the two, which means it goes further. So the 433 megahertz frequency of the Rako wireless is pretty damn good. It could go up to 100 meters in full open air, or 15 to 30 meters going through walls, depending how thick the walls are. And as I mentioned earlier, the battery life is pretty good because on the wireless keypads, they're only using power when you press a button. So they can last up to 10 years. So that's the wireless side of things. I hope that was useful, giving you a bit of an insight into the wiring of things, and see you on the next video.